This is the second part of a Level 1 Functional Skills Maths paper from AQA. In this part you can use a calculator. Question 1. Which of the following is the net of a cube? Circle the correct letter. Option D is the correct one. The rest of them are not nets of cubes. Calculate 52 squared. So as you can use a calculator, you could do 52 and the 2 at the top. So a symbol that you can find in the calculator to mean squared. Or you could just do 52 times 52 and it will give you the same answer. So that is 2704. Here is a regular hexagon. How many lines of symmetry does the hexagon have? So you might know this by heart because the number of sides tells us something. So there we have 3 and there we have another 3, so it's 6 of them. So 6 sides, because it's a regular shape, that is 6 lines of symmetry as well. A fair ordinary 6-sided dice is rolled. Write down the probability that it lands on a number greater than 4. Give your answer as a fraction. So it's a 6-sided dice, so it has 1, 2, 3, 4, 5, 6. It's also fair, so we include in all the numbers, and they have equal chances of being of landing on. So we've got to write down the probability that it lands on a number greater than 4. Greater than 4, that is 5 or 6. So how many numbers is that? 1, 2 out of 6. So 2/6 is the probability, or you could simplify it and go to 1/3, whichever you prefer. Measure the size of angle X. We'll need to use a protractor, so put in this at the center and then we start measuring. So your protractor might look slightly different, but the idea is the same. Start from 0 and see up to what point it goes. So that is about 130 degrees. Work out the number of minutes in 7 days. Let's work out in 1 day first. So in 1 day there are 24 hours. 24 hours, and that is 60 minutes each hour. So that will give us the number of minutes for 1 day. And that's 1440. 7 times 1440 gives us 10,080 minutes in 7 days. Write these fractions in order, starting with the smallest. Got 7/10, 3/4, 2/3. So as we can use a calculator, I'd suggest we convert this to decimals. And the way to convert them would be to go divide the top number by the bottom number. So 7 divided by 10, that gives us 0.7. 3 divided by 4 gives us 0.75. 2 divided by 3 gives us 0.66, and so on. So now we can decide which one is the smallest. So looking at the first digit, it's 0 for all 3 of them. So that means we need to look at the next digit. So that's a 7, that's a 7. This one is a 6. So that would be the smallest. So 2/3 is the smallest of them all. And then comparing these two. So now these two with the 7s, looking at the next digit. This one doesn't have a next digit, so that means it's a 0. And here we've got a 5, so this one is greater. For that reason, we're going to put 7/10 first, and then we're going to put 3/4. You could have converted them into percentages or just looked at them as fractions. All of them should be fine. Here are 7 numbers: 4, 12, 10, 13, 4, 6, 14. Work out the mean. So the mean means adding the numbers together and dividing by how many there are, so working out the average. By adding all of these numbers together, so 4 add 12, add 10, add 13, add 4, add 6, add 14. Using a calculator, you'll get 63. And there are 7 numbers, so 63 now divided by 7 gives us 9. So the mean is 9. Hotel. Vicky and Zach work part-time in a hotel. Vicky works on the reception desk. Her normal rate of pay is £9.65 per hour. She's paid double for working on a bank holiday. 1 week she works for 30 hours in total. 26 of these hours are at her normal rate of pay. The other hours are on a bank holiday. Work out her total pay for the week. So out of the 30 hours that she did that week, 26 of them are at the normal rate. So 26 times 9.65 gives us 250.9. Then that will be 4 hours left. So 30 take away 26 gives us 4. So 4 hours, that will be at the higher rate, which is double. So we could do 4 times 9.65 and then double that amount. And that is 38.6. So, and adding another 38.6 gives us 77.2. So we'll now do 250.9, add 77.2. Gives us 328.1. So that is £328.10. Zach is a porter in the hotel. He takes the guest luggage to their rooms. He is paid £8.10 per hour. Here are the hours he worked 1 week. So Monday 5 p.m. to 9 p.m, Thursday 3 p.m. to 6 p.m, Saturday 10 a.m. to 2 p.m. Was he paid more than £90 for the whole week? You must show you're working. So let's look at the number of hours done. 5 p.m. to 9 p.m, that is 9 take away 5 leaves us with 4 hours. 3 p.m. to 6 p.m, that is 6 take away 3 leaves us with 3 hours. 10 a.m. to 2 p.m, so from 10 a.m. to 12 is 2 hours. From 12 to 2 p.m. is another 2, so 4 hours in total for Saturday. How many hours is this altogether? 4 and 3 is 7 and the 4 is 11, so 11 hours. Now, what is the rate? That is £8.10. So we're going to do 11 times 8.1, and that gives us 89.1. So that is £89 and 10 pence. So was he paid more than £90? No. Zach gets £23.80 in tips from guests. He keeps 85% of this money. He gives the rest to Vicky. How much money does he give to Vicky? So as he keeps 85%, we can take that away from the 100%. So that leaves us with 15%. So that's how much he gives to Vicky. What is 15% of £23.80? So we're going to do 15%, 15 out of 100 of the amount, which is 23.8. So using a calculator, we'll do 15 divided by 100 times 23.8, and that gives us 3.57. So he gives £3.57 to Vicky. Zach wants to save £185 to buy a keyboard. He saves £35 each week. How many weeks does it take him to save enough money to buy the keyboard? So 185 divided by 35, it gives us 5.2857 and so on. So it's clearly over 5 weeks. So we're going to have to say 6 weeks. Because 5 weeks are simply not enough. Gardener. Beth is a gardener. Here is a sketch of a rectangular garden she is designing. Beth wants to cover 1/3 of the area of the garden with lawn turf. Lawn turf costs £2.75 per square metre. It can be cut to fit any area. Work out the cost of the lawn turf she will need. So we're going to need to work out 1/3 of the area of the garden. But first we need to work out the whole area of the garden. And looking at the dimensions, we've got 15 meters by 7.2. So 15 times 7.2 is 108 square meters. Now we need just 1/3 of that, so we're going to do 108 divided by 3, which is 36 square meters, and the cost is £2.75 per square meter, so 36 times 2.75, and that is equal to 99. So answer is £99. There will be a pond for fish in the garden. The pond will be a cuboid of length 2.5 meters and width 1.8 meters. The pond will be filled with water to a depth of 1.2 meters. 1 cubic meter is equal to 1,000 liters. Each fish needs 360 liters of water. Work out the maximum number of fish that can be kept in the pond. Okay, so let's work out how much water there will be. So we've got these dimensions: 1.2 meters by 2.5 by 1.8. So that will give us the capacity of the pond up to this point. So if we just do 1.8 times 2.5 times 1.2, which is 5.4 cubic meters. So how many liters is that? 1 cubic meter is 1,000 liters. So we're going to multiply 5.4 by 1,000, and that will give us 5,400 litres. So that's how much water there will be in the pond. Now each fish needs 360 litres, so if we divide 5,400 by 360, it should give us how many fish? And that is 15. So the answer is 15. Beth wants to buy some rose bushes for a flower bed in the garden. She sees this advert. £13.50 each, buy one get one half price. How much will Beth pay for 6 rose bushes using this offer? As she's buying 6 of them, she will get 3 of them at full price and another 3 at half the price. So we'll do 3 times 13.5, which is 40.5. And then the other 3 will be at half this price. So 40.5 divided by 2 gives us 20.25. So adding the two amounts together, 40.5 add 20.25 gives us 60.75. So that is £60.75. Concert. Anya is organising an outdoor concert. Anya is planning where to put refreshment stalls. There will be 3 rectangular food stalls, each measuring 6 meters by 2 meters. 2 square food stalls, each measuring 4 meters by 4 meters. 1 rectangular drink stall measuring 6 meters by 3 meters. There must be at least 2 meters of space between stalls. The centimeter grid represents a scale drawing of the area she can use. On the grid, 1 centimeter represents 2 meters. Draw a possible plan for the stalls on the centimeter grid. As the scale says 1 centimeter represents 2 meters, it will mean that the rectangular food stalls will measure 3 by 1 square. The square food stalls will measure 2 by 2. The drink stall will measure 3 by 1.5 squares. Let's try and draw them now. And also there must be at least 2 meters of space between the stalls, so that will mean 1 square. So if we start with a rectangular food stall, so 3 by 1, let's do another one. So that is 2 of them. And then we can do another one here. So that's the 3 rectangular ones. The square ones, 2 by 2. So we can do one here. And we can do another one here. That's done as well. And then one rectangular, which is going to be 3 by 1.5. So 3 by 1.5. Also got the 1 square space between them. Of course, you draw them using a ruler, which would be much easier when you do it on paper. Tickets to the concert will cost £55. There is an early booking discount of 20%. Work out the total cost of 3 tickets using the early booking discount. So the full cost of 1 ticket is £55. Getting 3 of them means we pay 3 times 55, which is £165. Now applying a 20% discount. So 20%, that is 20 out of 100 multiplied by 165, which equals 33. So there is a £33 discount. So we're going to do now 165 take away 33 gives us £132. The concert will start at 7:30 p.m. Anya wants to know when to open the gates to let people in. She wants to allow at least 30 minutes to check tickets and then 40 minutes for people to buy food and drinks. What is the latest time the gates should open? So the start time for the concert is 7:30 p.m. Anya wants to allow at least 30 minutes to check tickets. So if we go back 30 minutes, that will take us to 7 p.m. If you go back 40 minutes, from the 7 p.m, that will take us to 6:20, because there are 60 minutes in 1 hour, so taking away 40 leaves us with 20. So the latest time the gates should open is 6:20 p.m. Holiday. Jack is planning a holiday to Turkey. He finds this information about average temperatures in Turkey. On the grid below, draw a suitable diagram to show this information. We can do this on a bar graph or line chart, whatever you prefer. We've got 1, 2, 3, 4, 5, 6 months. So we're going to represent them horizontally. So we're looking at 6. How many squares do we have though? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we could do 2 squares for each month. We're starting with April. And these are months. So we labeled the axis. Now vertically we're going to represent the temperature. And what's the highest number it goes to? That is 28. Let's see, how many squares do we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if we do 2 degrees per 1 square, we could go up to 30, so that should work. So this would be 2. Of course, this is 0. So that is 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and that's temperature in degrees Celsius. So April goes to 16 degrees. Here is April, that goes to 16. And then we have May, that goes to 20. June 25. July 28. August 27. September 24. I could join the dots here and make a line graph, or add bars to make this a bar chart. I'm going to go for the latter, so making a bar chart. With pen and a ruler, it's going to be much easier to do on paper. Doesn't need to be perfect, as long as we've got the plotting that is very clear, as in where do the bars stop, keeping the bars of the same width, that sort of thing. You could colour the bars in as well, or leave them as they are. And one more to go. And we've completed the bar chart. Jack decides to visit Turkey in July. The table shows the costs for a holiday in July. Jack wants to travel on 12th of July and stay for 14 nights. He has £1,100 to pay for the holiday. Can he afford to upgrade to all-inclusive for all 14 nights? You must show your working. So he's traveling on 12th of July, which is this row here, 11th to 18th of July, and he's staying for 14 nights. So that is 14 nights, £760. Now it says upgrade to all-inclusive for £21.50 per person per night. Right, so 14 nights. We're going to do 14 times 21.5, £301. So adding that to the 760 gives us £1,061, and he has 1,100. So can he afford? Yes, he can. Jack will exchange some English pounds for Turkish lira. £1 is equal to 7.38 Turkish lira. Jack says, I want 6,500 Turkish lira to take on holiday. Work out the number of pounds Jack will need to exchange for Turkish lira. Give your answer correct to the nearest pound. So the conversion rate is £1 to 7.38 Turkish lira. Jack wants to convert 6,500, so we're going to put that under the Turkish lira. To get from 7.38 to 6,500, what do we multiply by? So to work that out, we do 6,500 divided by 7.38, which gives us 880.758 and so on. So we've multiplied 7.38 by 880.758 to get 6,500. So we must do the same thing on the other side. So 1 times 880.758. Now when you multiply a number by 1, it just gives you the number itself. So this is going to be 880.76. Let's just round it. And that is the amount in pounds. We've got to give the answer correct to the nearest pound. So we're going to say whether this is £880 or 881. Which one is it closer to? And as this is over 50 pence, we're going to go for £881. The table shows information about flight delays for 60 flights to Turkey. Estimate the probability that Jack's flight will be delayed by at least 1 hour. Use the data in the table. So at least 1 hour, it means 1 hour or longer. And looking at these, this wouldn't be applicable, neither this one. 1 hour to 3 hours, yes, this would be. And more than 3 hours, yes, that would be. So it's practically 8 and 3, that is 11 flights out of the total. So we've got to add 36 and 13 and 8 and 3, which is 60. So 11 out of 60 flights were delayed by at least 1 hour. And that's the answer. And this is the end of the paper.